Okay, they've asked us to evaluate another limit here. Now we know from our properties of limits, as we get close to 0, we're almost at the number 0, and eventually we go into plugging in what would be the number 0. But we can't do that in this one because what we're going to be doing is dividing by 0, which is, again, indeterminate. We can't solve that. Okay. So what we're going to try to do here is we're going to rationalize the top of this expression by multiplying by its conjugate. Okay. So again, we're going to multiply by the conjugate. The conjugate will be x plus 1 rooted plus the number 1. And we're going to multiply the top and the bottom of the fraction by this. When we do that, we're going to be evaluating the limit of x as it approaches 0. Now, remember we're doing our a squared minus b squared. So really we're just squaring the first term here. And when I square x plus 1, we're going to be left with just x plus 1. And then we're going to be subtracting 1 squared. Well, 1 squared is still just the number 1. So we're going to be subtracting the number 1. We've rationalized the numerator of this expression. And we're going to keep x on the outside here and just keep the rest of this rationalization at the bottom. The conjugate is x plus 1 rooted plus 1. When we simplify the top of this expression, we're left with just the x on top. So I want you guys to see that x plus 1 minus 1 creates a 0. And x divided by x creates 1. So we'll now have 1 on top of this expression. The limit of x as it approaches 0 is 1 divided by the root of x plus 1 plus the number 1. Now when we go to evaluate this limit, we can plug in a number that is infinitely close to 0 for x, which is essentially the number 0. This will now give us, sorry, I should have equal signs all the way across here. This will now give us 1 divided by 0 plus 1 is root 1 plus 1. Well, root 1 is 1 plus 1 is 2, so we have 1 over 2. So we were able to evaluate this limit because we rationalized it. Had we not done that, this would have been indeterminate. We wouldn't have been able to solve this limit.